Alright, the course final review, part 2. Here's the back side. Problem number 17 says simplify. Write the answer in standard form. So what we see here is two trinomials being added together. The second trinomial, we're not just adding the first thing, the 2x squared behind the parentheses there. We're adding all three of those terms. So I'm just going to draw some distribution lines saying we're adding all of those. It doesn't change things much. We're basically just going to be combining like terms. But if this was a negative sign right here, then we would be subtracting all of those. We would have to change the sign. All of them are positive. We would have to turn all of them negative. If a couple of them, one or two, were already negative, we would have to turn the negative ones positive. As it is, since there's a plus sign in between, it makes our job a lot easier. We can basically just take a look and find like terms. So we've got a term with an x squared in it. We have another term with an x squared. Go ahead and combine those together. And they're both positive, so 4x squareds plus 2x squareds gives us 6x squareds. Next we have a term with just an x. We have another term with just an x. So we'll go ahead and combine those. Again, both are positive. So if we have 9x's and we add 7, we should have 16 of those x's. It's just all about finding like terms if it has the same variable, or if it has no variable at all, or if that variable has the same exponent. So here we have no variables at all. Obviously 1 plus 13 gives us 14. So lastly, we have a 14. All of these were positive, so we can connect them with plus signs. And the last thing to check is to make sure that it is in standard form. And standard form means we start with the highest exponent. Got a 2 here. And then each following term has a smaller exponent. We can think of this as x to the 1 power. And then x to the 0 power just gave us 1, so we could put a little x to the 0 power behind the 14. However, that's just equal to 1, and so it would be just equal to 14. So starting with the highest exponent going down, we already have that, so it's kind of nice. It's already there for us. So we call this our answer. Alright, problem number 18, FOIL. So FOIL is a reminder to use distributing, but double distributing. F stands for first, or front. I think first. Either way, we're going to multiply the two first terms. The first term in the first parentheses by the first term in the second. The O stands for outside. So our two outside terms, the I stands for inside, our two insides get multiplied, and the L stands for last. So we've got 4 multiplications to do, so we will have 4 answers. 5w times 2w, first multiply the numbers together, 5 times 2 is 10, and w times w is w squared. Next up, 5w times 7, 5 times 7 is 35, and it's positive, so we'll say plus 35. And there's only one w in both of our terms, so we'll just leave a w behind it. It's still being multiplied by w. Now on to the bottom. Here are inside terms. Negative 6 times 2w. Negative 6 times 2 is negative 12. And of course, keep that w on board. Lastly, negative 6 times 7, just the two numbers times each other. Negative times a positive, again, is a negative, and 6 times 7, I believe, is 42. Alright, so we have FOILed it. For it to be in standard term, we have to combine any like terms. Usually your two middle terms are the two that are going to have the same variable with the same exponent behind it, so we can combine those. If we have 35 and we take away 12, I think we're left with 23. And we're talking about w, so keep the w behind. Before we just drop these down, the negative 42 and the positive 10w squared, just make sure that in doing so, we'll have it in standard form. We'll have our highest exponent first, followed by the variable just by itself. That's what this one ends up being, followed by the number just by itself. So that looks good. We'll just drop them down. 10w, since it's positive, separate it with a plus sign, and then minus 42. Looks very similar to the answer from the last one. Both of them are in standard form. We'll call it good. Alright, so factoring is the opposite of FOILing or distributing. So we start with a problem that looks like this, and we want to turn it into an answer that's going to look like two sets of parentheses with two terms in each one. So in factoring, if we do not have a number in front of the x squared, it makes our job a lot easier. What we need is to find two numbers that add up to give us our middle number, and they need to multiply together to give us that one. So the easiest way to start doing this is try to find numbers that multiply together to give us 72. Numbers that multiply together, we call themselves factors. So off to the side here, I'm going to give myself a 72, and I'm going to start listing the pairs of numbers that would multiply to give me that. The easiest one of all is 1 times 72, and as I'm doing this, I'm checking to make sure they might add up to that. This is way too high, right? 1 plus 72 would give us 73, so we'll keep on going. Basically asking ourselves if it's divisible by the next number in the list. If it's divisible by 2, then we should be able to find a number 2 times that will give us 72. Well, it is an even number. All even numbers are divisible by 2. So we do that. We go ahead and cut 72 in half. That gives us 36. Add those together. That's still way too high. Let's try 3. And just by looking at it, if there's a 36 in there, I know 36 is divisible by 3, so I know this is going to work. I don't know exactly what it's going to give, so I guess this is where I'll grab my calculator. 72 divided by 3. Let's kind of put it over here where you can see it. Okay, 72 divided by 3 is 24. Still too high. Let's try 4. And since we already cut it in half once, if we cut it in half again, the answer to that will be whatever 72 divided by 4 is. So 36 cut in half should give us 18, getting closer, but still way too high. Finally, we get to a number 5 that won't work. For a number to be divisible by 5, it has to either end in 0 or 5, which 72 does not. So I'm going to get rid of the 5 there. I do believe 6 will work, because if we take the 24, which we got from dividing 72 by 3, and we cut it in half, that should give us what 72 divided by 6 is. So 72 divided by 6 gives me 12. So close. We're looking for numbers that add to 17. This adds up to 18. 72 divided by 7 is not going to work nicely. So we'll try 8. That should give us 9. And I think finally we have found our two numbers. 8 plus 9 equals 17, that middle number. And so those are the two numbers we're going to plug in to our pair of binomials. So give ourselves a pair of parentheses. Put x's in the front since x is the variable we're using. And then take those two numbers, both of them are positive, and put them behind there. And that is our answer. We can double check that it is by doing the opposite of factoring, which is distributing. And if we were to take and FOIL all of these, we would have x times x, which is x squared. We would have x times 9, which is plus 9x. On the bottom, 8 times x obviously is 8x. And then finally, 8 times 9 is 72. Once we combine these two like terms in the middle, 9x plus 18x gives us 17, and we would end up right back where we started with those three terms. So since we were able to reverse the process and end up back where we started, we know that we got the right answer, which is that pair of binomials. Problem number 20, solve for x. This is easier than the one above as far as solving for x, because we only have one variable with an x in it. So before we had to get rid of the exponent of a 2 by factoring. Here we can just do the opposite of exponents, which is square roots. But we're going to treat it like one of the problems from part 1 first, where we need to isolate that x. The thing furthest away from the x is the negative 25, so we're going to want to get rid of that first. And also, we use the opposite order of operations. So we're going to start with either addition or subtraction, and then move ourselves backwards from that. So if there were division or multiplication to do, we would do those, and then the last thing we would do is parentheses and exponents. So I'm going to add 25. Negative 25 plus 25 cancels, and I need to add 25 over to the other side as well, keep my equation equal. Go ahead and rewrite that as x squared is equal to 0 plus 25, obviously is 25. And then we're going to do the opposite of a square. That is the square root. The sign for square root looks like this. And so if we take the square root of a square, then they cancel each other out, and we're left with just x. Keep it equal, take the square root of the other side. Square root, since it's the opposite of the square, it's the answer to the square root is the number that times itself gives us that 25. So you can punch it into the calculator, square root of 25, or you can just think to yourself, what number times itself gives you 25? And you guys probably know what it is, but go ahead and here's your square root button, and 25, and it's equal to 5. So obviously 5 times itself gives us 25, and we've found our answer. There is one little trick here, though. There's one more number that we can multiply times itself to give us 25, and that is a negative 5. So anytime we do a square root like this, it's equal to both the positive and negative version, because 5 times 5 gives us 25, but also negative 5 times negative 5 gives us positive 25. So we have two answers. Just the positive and negative version of the same number. Alright, so that was 20. I think we've got two more on the back side here. So taking a look at 21. This one has two variables with x's, and we cannot isolate the variables by doing opposite order of operations, because if we take away 7x from both sides, we're still going to have that. We're just going to have a negative version of it, negative 7x over here, and we just really cannot get these get the x by itself or get rid of the exponent. If we get rid of the exponent, then we could combine like terms. But since they are not like terms, we're stuck with both of them, unless we could do two things. We could either factor, which sometimes works, if you can find two numbers that multiply to give you the two last ones. Or what always works is using the quadratic formula. That's why it says do that right there. So quadratic formula, if you look it up in the book, it's negative b plus or minus the square root of b squared minus 4 times a times c. All of that gets divided by 2 times a. So we got to figure out our a, b, and c values first. In order for this to work, we have to set it equal to 0. So we need to make it, this number is 0. The opposite of negative 10 is plus 10. I'm going to put a little plus 10 on the other side as well. And now we have it equal to 0 over here, and we have these three terms. I'm going to write them in standard form with our term with the largest exponent first, so negative 3x squared. Second term, plus 7x, and then I'm just going to slip plus 10 in behind it. And now we have our a term, which is just the negative 3. Got our b term. And if there's a negative in front of any of these, make sure you keep the negative with it. And then the c term is just the number by itself. I'm going to go ahead and label those a, b, and c. And now I'm going to take that quadratic formula right here, and everywhere I see a letter, I'm going to plug in the number we found that corresponds with it. So we start off with a negative b. Anything I plug in, I'm going to put in parentheses. So there's a negative, first of all, from the formula, and then our b value of 7. The formula says plus or minus square root, and then there's that b underneath, so I'm going to plug in 7 one more time. Make sure it gets squared, and then minus 4 every time you use this formula, and then a times c. So whatever a is and whatever c is. A is my negative 3, and c is my 10. And on the bottom, 2 times a, and a again is negative 3. So now it went from algebra to just a regular math problem. Kind of a complex one with all kinds of operations, but still no letters, just numbers. So we're going to take a look at what is inside of the square root first. We're going to simplify that down. We can, when we recopy that negative 7, we can get rid of the parentheses. Since there was no negative 7 that we plugged in, we don't have to worry about a pair of negatives. And so we can just write that as minus 7 plus or minus. And we're going to do each of these separately. We're going to do 7 squared. 7 times itself is 49. And then we're going to multiply all three of those together. So negative 4 times negative 3 should give us positive 12. And then positive 12 times 10, just add a 0 onto the 12, and we end up with positive 120. On the bottom, we can go ahead and simplify 2 times negative 3 as well. 2 times 3 is 6, and obviously positive times a negative is another negative. So we've got it a little bit more simple. The next step down, let's again solve what's inside of the square root. So negative 7 plus or minus, keep the same. Instead of saying the square root of 49 plus 120, I'm going to add those together to give me the square root of 169. And I'm going to keep my negative 6 on the bottom. I'm going to use my calculator to find the square root of 169. Square root 169. Oh, it's 13. nice whole number, no decimal. If it was a decimal, maybe round to the 100th, 2 places behind the decimal, and you'd be just fine. I'm going to go and write that as -7 plus or minus 13. Just replace the square root of 169 with the number 13, its answer. Keep that -6 on the bottom. And now we're going to deal with that plus or minus sign. So we want to do both of those operations. So we're going to split this into 2 equations, one where we have -7 plus 13 all divided by -6, the other one where we do the negative version, so -7 minus 13 all divided still by -6. Alright, -7 plus 13, one's positive, one's negative, so we got to subtract those and make the answer positive since our positive number is larger. I do believe that gives us 6 divided by -6. We can go ahead and do that division really quick. Anything divided by itself is 1, and a positive divided by a negative is a negative. So there's one of our answers. On the other side here, both numbers we're combining together are negative, so we're going to have an even larger negative number. 7 plus 13 gives us 20, and we're still divided by 6. There's 2 ways we can write the answer for this. The first way, we can either write this fraction in its simplest form. It's okay if it's an improper fraction if we have a larger number on top than on bottom. But we look for a number that we can divide both of them by. They're both even, so we can certainly divide both of them by 2, and I'm going to make it by a -2, so that we'll make everything positive. -20 divided by -2 gives us 10. And then on the bottom, again, negative divided by negative makes it positive, and 6 divided by 2 is 3. So there's one of our answers. The other way we can just do this is just divide, treat this fraction like a division problem. And we can type in -20 divided by -6, negative divided by negative is a positive, and 20 divided by 6 is 3.3, with 3's going on forever, so I'm going to put that bar above it for 3.3 repeating. And so either one of those works. I'm going to stick with the decimal version, and there's our 2 answers. X is equal to -1 and 3.3 repeating. Alright, last problem. The veterinarian examines 9 cats. The weights of the cats are listed right there. Highlight them. So 1 weight, 2, 3, 4, 5, 6, 7, 8, 9 cats. There we go. We want to find the mean and median and mode of the data. And we're asked, in our opinion, which measure of central tendency, which one of those 3 best describes the data. So let's see here. The mean is the first thing. So the mean is our average. So I'm just going to take all of those numbers and plug them into my calculator. Added together. So we got 13.4 plus 13.1 and 10.7, 6.8, 11.4, 10.8, 13.4, 11.3, and then the last one of 9.3. Add those together, and that gives us 100.2, and then I'm going to divide that by the number of cats we have. So 9 of them. and that gives me 11.1333 repeating. It does not say what to round it to, since all of these are rounded to the nearest tenth. They only have one number behind the decimal. We'll make this one only have one number behind. So behind the 11 here, we have a 3. So we should keep it rounded down to 11.1 would be a good mean. And the median is the next one. In order to find the median, we have to put them in order from least to greatest. So I've got a couple. I've got a really small category here, 6.8. And then I've got one more that's in the single digit with the decimal behind it. So we've got a 9.3. And then just moving up, we got a couple of in the tens. We have a 10.4 and a 10.8. I'll cross these out as I go. So I got 4 written down, I got 4 crossed out. In the 11s, we got 11.3 and 11.4. Any 12s? Let me grab any 12s. And then we do have some 13s. We have 13.1. And a pair of 13.4s. Running out of room here. 13.4. I think I got all 9 of them. And so we need to find the middle one. That'll be our median. I'm going to cross out, or in this case highlight, the 2 very furthest end ones. And then I'm just going to keep on moving towards the middle. Okay, I got 2 on either side. Now I'll put 3 highlighted on either side. And now 4 highlighted on either side. And that should very clearly point out our median of 11.3. And then finally, the mode. The mode is just the number that we see the most. And when we got to the very end here, we noticed that we saw 2 casts that weighed exactly the same. So we just look at the number that occurs most often. That 13.4 occurs twice. So we're going to say mode equals 13.4. And we've got all 3 of those answered. Find the mean, median, mode, and then which one best describes the data. So the mode certainly does not. That's not the middle number. That's the very highest number. So it's between 11.1 and 11.3. And if we take a look at the spread between these two, and we see which one of them is furthest away from the median. So if we take 13.4 and subtract the median from it, 11.3, I think we end up with 2.1. On the other side of things, if we see how far the smallest number is, our minimum, from the median, so we're going to start with 11.3 and take away 6.8. I do believe that would give 5 in the back and then a 4. So we have quite a few numbers, or at least it goes a lot further below the median. So I would say that in this case the mean, both the median and the mode, are a little bit too high to let us know that we also have numbers as low as 6.8. So the mean in this case, I would say, is the best. Alright, so that was kind of a long video. You can save it for tomorrow, this one. I'll mention that before you even start this thing. But I'm thinking if you followed along with all of these problems, then you've got by now the front and back of each part, so 4 video sessions, and in your notes from these sessions will be really helpful for the test. So good job getting to the end of the video. It should be maybe Thursday, maybe Friday. So see you guys in class on Monday virtually. Have a good weekend.